Today I am gonna start the design of a tall building using ETABS version 18. Where the building stories will be the 23 stories, and here is the building configuration that is shown in this picture. This is a Skyfi Lab project. Where this is the story structure and this is the building what I am gonna have to design. These are the stories 1 to 8, where dead load is 2 kN per meter square, live load is 5 kN per meter square. From story 9 to 14, the dead load is 2 kN per meter square, live load is 4.5 kN per meter square. From story 20 to 23, the dead load is 2 kN per meter square, live load is 3.5 kN per meter square, where story 15 to 19, dead load is 2 kN per meter square and live load is 4 kN per meter square. These are the columns and beam sizes, where the columns will be 500 by 500, 550 by 550, 600 by 600. The beams will be the 500 by 300, 550 by 350, 600 by 400. We will just do it using the auto select beams and columns. And had the grade of concrete that is taken is M40, and for rebar main bar HYSD 500 and mile 250 that is used. The slabs that are used, concrete grade of M40 having thickness of 150 mm. Auto draw cladding has been used, where the cladding load is 0.2 kN per meter and we will consider the wind load, where the parameters will be in Bangalore. So I am gonna start a new model. Now after coming this dialog box, we will see that the model initialization I am gonna have to use the built-in settings, where the display units, that is metric SI, steel section database Indian, steel design code as IS 800 2007 and concrete design code as IS 456 2000. Sorry. So after giving this data, I will just OK it. Now I will keep it open, make it easy. Okay. So here in this question, I can see the number of grids that is shown. The 4 grids are here in the X direction and in this direction. So these 4 grids are here and the spacing is 6 meter in all the cases. And after selecting these grid numbers and the spacing, I will have to do the master story setup. I will just show it over here. These are the 4 grids. The spacing of between them is 6. Number of stories is 23. Story height is 3 and 3. So just use the custom story data. Over here I can see the story 23 is considered as master story, that is right. And in this given question I have seen that from story 1 to 8, 9 to 14, 15 to 19 and 20 to 23, these are the 4 types. So here I can just choose master story as 19, 14 and 8 and make the rest of the stories similar to these stories respectively. I will just do it in this way. Story 20 to 23 is given over here, that is similar stories. Story 15 to 19, I will take story 19 as a master story, and from 15 to 19 they will follow story 19. from 9 to 14 it is similar. So 14, I will just take 14 as a master story. Where from 9 to 14 will be similar to 14. And I will take story 8 as master story. Story 1 to 8 will be similar to story 8. My story selection is done. I'll just click OK, click on grid only and OK. Still my project is untitled. Now I will just name it up. Here is a grid that is shown over here. For better working, I will just name it save as. This is showing the story 23. Now using this arrow I can go to story 1. This is what it is. Now first I will just do the define, then I will give the material properties, add new material, region as India, material type is concrete Indian, and here M40 that is used here. Just OK it. Use the bar HYSD grade 500, that is Indian, so it's OK. OK it. Just change it to grade 250, OK it. Click OK to close this bar, this window. Now in define, in section properties I will click on frame properties and defined column sections will be chosen. What are the column sections that is told? 500 by 500, 550 by 550, 600 by 600, and the beams 500 by 300, 550 by 350, and 600 by 400. I will just take some values more than these values that are given over here to complete my design in one go, because I am going to use the auto select, and this software will choose the smallest section and the smallest sections that will be required to design this building successfully to carry the load. So 500 by 500, 550, 550, and 600 by 600. Now I will just add a new property, concrete rectangular, choose concrete, 500 by 500, 500 by 500 and 40, 500 by 500. Modify show rebar, we just consider it as column. Here it is column, and here I will just give longitudinal bar HYSD 500, confinement bars or ties as HYSD 250, mild steel mild 250, and the clear covers is 40 meter. That is okay with it, and just click on OK. Just close it by clicking on OK. So this is the column section 500 by 500. Now I will just add 550 by 550, 600 by 600 and other sections similarly. So I will just add copy of the property to keep other things as similar to it, not change the rebar sections. The M40 that is shown 550 by 550. If you just modify showing rebar, you will see that the things of the longitudinal bars, confinement bars that were chosen previously is similar to the previous one. So just click on OK, and the depth of change, OK, add copy of the property. See 600 by 600 M40 that is shown 600 okay. Similarly see 650 650 650 650 okay. See 700 700 700 700, click on OK. See 750 and the last one. Okay, I'll just add it, and I will go to add new property, auto select list. Now after column auto select, giving the column sections in the column auto select, here you can modify the show property. Here I can show that the columns are added in this manner by giving this add section, and I will show about the beam sections, and the beam sections that are selected here, that are added here in the similar manner. Here you can see the modify and the show property. This is the beam section, this is the material, and this is the depth and width. And in the reinforcement, this is the way it is selected. This is the HYSD bar, longitudinal bars, confinement bars, mild 250, where the covers are given as 25 millimeter for top and bottom bars each. And now I will give the beam auto select section, just rename it a bit. In case of the columns, it's right. And I will just similarly add a new property, auto select list, and I will give beam auto select, choose concrete, select the beams, and I will add them. The beam sections will be added over here, and just choose OK. In this manner, the different beam sections and the column sections in case of the design will be taken by the software itself, and the smaller size will be taken. Now that in the defined properties, the material properties and the section properties are given, now I will have to draw the columns on the structure depending on the plan views and the stories, similar stories. So I can see from story 1 to 8, which will be considered as similar story. This is the plan view and this is the position of the columns. I will use the shortcut keys for the columns and beams to draw the structure, as if this is a quick draw for columns. First I will go to the story 1, and in the story 1 I will choose the properties similarly in this manner. Okay, first click on, this is the story 1, and first click on similar stories, not the all stories, the similar stories 1 to 8. Let's click on quick draw columns. Here, before drawing columns, I will have to take or choose the property of the columns. Here I can select column auto select, and as per the plan, the entire one will be selected. Okay, so I will select the entire building plan for columns. Similarly, I will choose the beams, and from the property I will change it as a beam auto select, and draw beams. But I haven't selected the slab sections, so I have to select the slab sections before assigning it to the structure. So I will just escape it, and in the define menu I will add slab sections, add a new property, slab 150 millimeter, that will be chosen, the concrete M40, shell thin, and here the slab thickness 150 millimeter, that will be chosen here. Okay, to close it. Now from here I will choose the slabs for quick draw floor and wall. After choosing it, I'll go to the slab property. Where is the 2D? Here is 2D diagrams, and I'll just choose the property of the slab from slab 150 M40 concrete. Here the similar story is already selected. Select the tier 1 and draw it at once. These are the slabs that are drawn here. After that, click on escape. This is from the story 1 to 8. This is from story 1 to 8. We'll go to 9. See the progress of it. This is 6th story. So I am in the story 10 exactly. So I know that from story 9 to 14 the columns, beam and the slab positions will be in this manner from 9 to 14. I'll just choose similar stories in the exact manner. And this is story 10. Take any one of the stories. Quick draw columns. Column auto selected. Select the columns that you want. From this to this, columns are selected. Quick draw beams. In the similar manner, select the beams and after selecting or drawing beams, I will just draw slabs in similar manner. Slab 150 is chosen already, so draw slabs. So for similar stories, the beam, columns and slabs are drawn from 9 to 15, 9 to 14. From 15 to 19, I will choose from 15 to 19 for similar stories. Add columns, selecting the columns auto select. In this manner, select the beams. By beam auto select and select the slabs in similar manner. And next 20 to 23. So yeah, for 20 to 23 can draw it in the similar manner for the columns, and for beams, for slabs, that click on escape, and here the beam sections, column sections and slab sections are added. Now I will add the dead load, live load and cladding load in a similar manner. Just go to story 1, select it easily. First of all, in the base section, just go to the base section and choose one story, select the joints and assign joint restraint as a fixed joint, apply and OK to close it. The fixed joint is applied. Here in this picture you can see it. Now go to next floor, story 1. Now we will give the dead load to the entire structure, which is 2 kN per meter square entirely. Live loads will differ. So in all stories I will select the shell members and give a dead load of 2 kN per meter square. The entire building and the entire floor slabs are selected in this manner. Wherever the slabs are absent, those portions will not be selected. I will assign shell loads, uniform load, dead load. It is 2 kN per meter square that is given in this question. Apply and OK. The loads will be given or assigned on the shells. After that, I will have to assign the live loads throughout the structure using the similar story concept. This is the story 1. Change it to similar stories, and what are the live loads? Live loads are 5 kN per meter square, so select the shells first. You can see that only the similar stories are selected. In the similar story, I will give the live load 5 kN per meter square. So we'll assign shell loads, uniform, change it to live. It is 5. Let's check it once more. Apply and OK. In the similar manner, I will go to the 9th story. I can also choose it in separate way if it takes too much time. This is the 8th story. I can see it in this manner, the plan view, and I want to see the 9th story, 1 to 8 are similar, so 9th story, just apply OK. I can see the 9th story instantly. Now click on the shells and apply live load on it. This is shown as live. There is no live load that is being applied on it. Select them, select the similar stories only. So all slabs that are selected, assign them with the live load of 4.5 kilonewton per meter square. So it is 4.5 kilonewton per meter square. Apply and OK on the similar stories. In similar manners, 9 to 14 and 15 to 19 and 20 to 23. So I will go to 15 to 19. Plan view, 16, apply OK. This is for 15 to 19. Select the shell members, assign, this is 4 and for next it is 3.5. Go to story 23, apply OK. Select the slabs, assign shell loads as 3.5 kilonewton per meter square. Only these two, it is the live load 3.5. This is applying on it and OK. Similar stories are selected here. So dead load and live loads are being assigned on it. Now I will give the cladding load that is given in the question as 0.2 kilonewton per meter, and so to do that I will very carefully have to select the external beams to give cladding load 0.2 kilonewton per meter. Similar stories, external beams that is selected here. You can check it in the 3D viewpoint views, and in the similar stories that is selected, I will just assign frame load distributed, the load pattern name dead cladding load 0.2. We know that in the roof this cladding load is not applied. In the similar stories this load is applied, but in the roof it is not applied. So I will have to delete it, show the undeformed shapes, click on undeformed shape. I will get the select on one story, and this is in the story 23. Select the external beams, and here cladding loads will not be there because there is no wall over here. So assign frame loads distributed, delete existing load for one story, apply and OK. For rest of the other members, I mean for other stories, rest of the other stories I will just have to select them one by one. For plan, for story 1 to 8, any one of the stories can be selected. This is taken as a story 4. I will just select the external stories. There it is said the frame span loads gravity dead. That is the cladding load. So I will just select the external beams in this case. You can check it here as 12 frames are selected. So I don't want only these 12 frames, I want the entire one. So I'll just click on escape and display undeformed shape to get this option here. So click on similar stories and select the external beams. Previously only 12 frames were selected. Now 8 into 12, 96 frames are selected because of giving the similar stories. And I will add it, I will assign them with the cladding load of 0.2. Here is the dead load. Apply. Okay. Cladding load is being applied. Now for the next story, that means from 9 to 14, I will go to any story. Let's select 10, apply. Okay. Select the external walls carefully in the similar story pattern. And we can see 72 frames are selected in the similar way. 12 times from 9 to 15 the number of stories that are selected. I will just assign frame loads distributed 0.2 cladding load. Okay. For 9 to 14 this is given. Now I will just select from any stories from 15 to 20. 15 to 20 I will select it's given 15 to 19, so I will select 16th story. Go to plan view, 16th story, apply. Okay. Now select the external beams. Display undeformed shape is shown. The similar story is already selected. Select the external frame member in this way. And apply cladding load on it. Then go for auto cladding. This way this entire frames is selected and assign distributed cladding load in this way. And now we'll go to auto cladding, auto draw cladding, use floors, click on OK. Entire 3D view will be shown. This is the entire 3D view. Save it, save the model. Now in the define section go to load patterns, add wind load, load type is wind, IS 875 1987, that is added, this new load is added. Now this wind load will be modified. Clicking on modify lateral load section. Now the wind coefficients will be selected based on IS 875 1987 code, that is in my coursework section. In this section, if we go for wind speed, I am just designing this building for the wind load, consider the parameters in Bangalore, so I will take wind speed in this section. So I will consider wind speed as 33. Consider wind speed as 33. So take this value. The terrain category in Bangalore, the terrain category is this. See, this is in the category 3. This is in the terrain category 3, and the structure class the structures and or the components such as cladding, glazing, roofing, these are greater than 50 meter. Yes, so in our case this class will be the class C. The risk coefficient values, that is this taken from this one. We will take the design life for the structure as 50 years. Risk coefficient K1 values will be 1, and the topography K3 factor in this case K3 factor will also be taken as 1 because of this one. The upwind slope is greater than about 3 degrees or below, that is the value K3 may be taken as equal to 1. So consider it. Other things as it is, click on OK. Click on OK to close it. I will assign the wind load, frame load, not the sail load, the wind pressure coefficients. Load pattern name is wind, that is alright. Now the coefficient. Now how can I find out the coefficient? Now I will go to code. Now the external pressure coefficients for the walls of rectangular clad building. What is our height? What is our height? Height of our building is 23 stories into 3, that is 69 meter. So the 69 divided by its width, that is 18. So this section will fall in this one, h by w, that will be within 3 by 2 to 6. It is also a square platform, the square plan that I can see in this manner in this question. So this row will be used for CP, and in the A side, that means in case of the plan, if we just go to plan of the story 1, you will understand it very clearly. This is the plan view, and here I can see, if we compare it with the code, we will see that this section, A section, is A section in this case, and this D section is given as B in this code. So this is the value of A, D respectively, and this C section is actually section 4 in this case, and D section is actually section 1 in this case. This is what section C is 4 and section D is 1, that have been shown over here. These are leeward, only one is windward. So we'll take this value accordingly. Just assign frame loads, cell loads, wind pressure coefficients, and this is so I will have to select the sections first. So I will click on the elevations and select the section A, this A section, that is the section A in this case, A. So click on section A, okay. This is the elevation view. Now select the all stories and click on the shells in this manner. Now this entire section will bear the wind load having the wind coefficient that is given as per the code, highest code, that is plus 0.8. So I will apply it. Assign shell load, wind pressure coefficient, wind load plus 0.8. This is the windward direction. Apply it and OK. Similarly, just some section from this is in case of the A. This is, let me show this manner. This is the section A, but you can see from this diagram that some section of the section B that is also taking load. So I will just select this section B, go to elevation, section B, that will take the windward force, some of it that is exposed to the windward direction load or wind load, let us say. So apply, OK. These are the sections what I was talking about. Select the shells by clicking all stories, and now apply the windward load, that is shell loads, wind pressure coefficients of this one. Apply it on this direction and OK. This is the windward load. The other sections or the other sides, as if from the B side, that means C and D will face this leeward wind load or wind coefficient of minus 0.25. What you can see in this case, plan view from story 1, apply OK. For C and D, we will choose elevation C. No, first I will select the D, C and D, apply and OK. All stories are selected. In this case, this is the D side. Select the shells in this manner, and I will go to the next case of the C. I will also select them in the similar manner. These shells are selected and these shells are also selected, and I will assign them wind load, assign the wind pressure coefficient of minus 0.25. Minus 0.25. This is the leeward sides. Apply and OK. In the similar manner, we will select the other sections that are elevation sections, that are 1, 2, 3, 4. All will face a leeward wind having the coefficient, that means 1, 2, 3, 4 will face the leeward wind of having the coefficient of minus 0.8. So we will select this, all of them significantly, select all of them one after another. Okay, this one, this one, this one, this one. 1, 2, 3, 4 all have been selected, and all will be assigned a wind pressure coefficient of minus 0.8 as per codal provisions. Leeward wind, apply OK. So wind load is applied. Now we will go to load combinations. There is no combination that is shown over here, so we'll add default design combination. Here in this section, I am gonna select the concrete frame design and click on OK. Here these are the loads, defined loads that is acting on it, which is being shown. These are the load combinations. Click on OK. Now this is the plan view of the story 1. This is the wind load coefficients. The load case is selected, everything is done. Now we will analyze the structure. Run analysis. This tall building is being analyzed. The progress can be seen in this section. After analysis, the 3D view is shown over here. If we click on any structural element, we can see the joint element and the story, respective story in the reactions, the loads. Now we will design it, concrete frame design. Select the IS 456 2000. Select on start design and check. After checking or clicking on the extruded form, the structure will be designed automatically and the sections will be selected. We'll click, do you want to reiterate analysis and design? Select yes. Design will be done automatically. Now the sections will be redesigned and modified. After changing the section characteristics, which can be seen over here. This thing is happening because we have already selected the beam auto select and column auto select, so it will automatically select the next section size of the beam and the columns. Here we can see that differs for 11 concrete frames. It has came down to this many numbers, and so I will just rotate analysis and design again. It is analyzing. In this way this building will be designed, and still 6 concrete frames. And this will be redesigned automatically. Select the next section for those 6 members that has failed. Here after design we are gonna check whether verify all members are passed or not. We can see that all concrete frames passed the design check, and now I will go for the project report. I go to project report. This is the project report, and here you can check whether what are the area connectivity, what are the mass source definitions, is the material properties. If you go click on this thing, these are the material properties that is given over here. If we click on 100%, this is the properties that are added. These are the beams, these are the columns, and this is the area modifier that is given here, and different stories, different names, different form areas, diagram, and everything has been selected categorically. And the entire story, the beam and columns that are selected, we can see what are the column size for which kind of beam. And this is the frame assignment. This is a column auto select. It is clicked as column 500 by 500 is selected in this case, but here some cases we will see that column size may vary, as if we will go to the story 1, we can see the column size may vary significantly. This is the column size, these are the beam size, and beams size for different stories, and these are the shell assignments, this is the shell properties, and these are the loads, wing loads, auto wing loading, this is the wing load calculations, this is the area load assignments, this is the frame load assignment, and this is the summary report, we can check. You can see the load patterns, different load patterns, story definitions, structure data, load pattern definitions, different load patterns, and these are the response spectrum functions that can also be seen over here. These are the story drifts that is shown here, the story forces that can also be seen from these values. Congratulations, we have just finished the design of a tall building. Thank you.